started some important short questions on the conductors and capacitors part. So first questions which we will discuss today: what is the electric dipole? If two opposite charges plus q and minus q are separated by some distance d, forms the electric dipole. The distance traveled by the point charge is defined as the dipole moment, or the product of charge and distance traveled by is called the electric dipole. So the distance traveled by the point charge is defined as the dipole moment or the electric dipole. If there are two charges plus q and minus q, both are of the equal magnitude but opposite in direction, we can write P is equal to QD, where P is the electric dipole moment, D is the distance between the opposite charges between the line is called the axis of dipole. Give the relationship between the electric field intensity and the electric potential. Electric field intensity is equal to the negative rate of the electric potential with respect to distance. I have already discussed in details in my last lecture, so you can see from there, but here just again one little discussion. Electric field intensity is equal to the negative of the rate of change of electric potential with respect to distance. It can be defined as the negative of the rate of derivative of the potential V with respect to R. E is equal to dV by dr, or we can write it E is equal to grad of V. What is polarization? If the dielectric or insulator placed between the charges plates of a condenser, then the center of gravity of the negative charges is concentrated towards the positive plate, and center of gravity of the negative charges is positive charges concentrated towards the negative plates. This process of separation of the opposite charges is known as the polarization. So if there is one charge, so if we connect it with the battery, the negative charge will be attracted by the positive charge and the positive charge will be attracted by the negative cathode. So there will be a separation of the charge, which is known as the polarization. Polarization is also defined as the electric dipole moment per unit volume. The polarization is known as also the electric dipole moment per unit volume. Let A be the area of cross section of dielectric, I be the distance of the opposite charges are separated, Q is equal to total charge in volume of dielectric, then polarization is equal to dipole moment per volume is equal to Q by A, and the unit is coulomb per meter square. So the polarization is equals to the mathematically or numerically equals to the surface charge density, but in the practical case there is no relation between the surface charge density and polarization. Discuss the permittivity of the medium, the ability of the substance to store the electrical energy in an electric field. So what is the next question? Define the dielectric constant. The dielectric constant is defined as the ratio of capacitance of a capacitor with the dielectric to the capacitance of the capacitor without dielectric. So what is the dielectric constant? We know the capacitance is equal to epsilon A by D, and for the same capacitance we can write the epsilon naught A by D. So what is the dielectric? Dielectric is the ratio of C by C naught, and we will get the capacitance epsilon by epsilon naught. Dielectric constant is the ratio of the capacitance of the capacitor with dielectric with the capacitance of the capacitor without dielectric or with air or free space. With the ratio of the permittivity of the substance to the permittivity of the free space. The dielectric constant is always a now define the capacitance of a capacitor. Capacitance of a capacitor is defined as the charge Q developed between the plates when the V is applied. When we are giving a applied voltage V, the capacitance of the capacitor, the capacitance means number of charge developed in a capacitor. We can write the basic capacitor elements are formed by separated two parallel plates with some dielectric medium. When some voltage is applied, such element charge is formed and charge is stored in the plates, and we can write that the capacitance of the capacitor of the charge Q between the two plates V is applied can be written as the C equals to Q by V, charge per unit potential. What is the unit of the capacitor? The unit of the capacitance is farad, and most generally we use the capacitance epsilon. C is equal to epsilon A by D for a parallel plate capacitor. Though the capacitance are in farad, but generally which capacitance we used in our daily life are in the microfarad or picofarad range. Now we are moving to our next question, capacitance between parallel plate. The capacitance between the parallel plate. So we have to calculate the parallel plate. This is up to parallel plates. The distance between these two are D. So we let there is a potential applied to the plates is V, forming the charge Q. So the electric flux density between the plates is D is equal to Q by A. We can write the electric field density, electric flux density is equal to basically psi by A, and from the Gauss law we can write psi is equal to D. Now what is D? D is equal to epsilon into E. So we can write epsilon into E is equal to Q by A. We can write epsilon D is equal to Q by A. So what is E? E is nothing but the Q by epsilon into A. What is potential? Potential V is equal to D. So we can write Q by, we are multiplying, E is equal to V by D. E is equal to, just we discussed, V potential by the distance. Here the distance is nothing but the D. So E can be written as V by D. So V is equal to QD by epsilon A. Now what is the definition of the capacitance? Capacitance is equal to V by Q. Capacitance is equal to Q by V. What is the, or we can write, then here we are taking small q by QD by epsilon A. So we are getting epsilon A by D. So this is the capacitance for a parallel plate capacitance. This is a capacitance for a parallel plate capacitance. Now if the dielectric is the free space, we can write C is equal to epsilon naught into A by D. We can also write for a parallel plate epsilon naught by epsilon naught A by D. And what is epsilon? Epsilon is equal to epsilon naught into epsilon R. Epsilon is equal to epsilon naught into epsilon R. Write the expression of the capacitance of a coaxial cable. So we are thinking about a coaxial cable. This is an axis. So we have to calculate the potential of an coaxial cable. So first we have to calculate the potential. What is the value of the V? V is equal to, we know, Q by 2 pi R. Q by 2 pi R. And what is this? From the outer side to inner side. Outer to inner. So what is this value? This value is, and this is the minus Q by 2 pi, not R square, 2 pi R. So what is the value? Q by 2 pi is a constant. So we are getting 1 by R A to B. B is the radius of the outer and A is the radius of the inner. So I missed the epsilon. 2 pi epsilon 1 by R is nothing but the ln B minus ln A. So Q by 2 pi epsilon ln B by A. Q by 2 pi epsilon ln B by A. Now, if we know the V, what is the capacitance? Capacitance is equal to Q by V. So, if we write the value of the V, we will get 2 pi epsilon ln B by A. 2 pi epsilon by ln B by A. So, this is the value of the capacitance. Write the relationship between the electric flux density and the intensity. The relation between the electric flux density and intensity D is equal to epsilon E. We know D is equal to psi by A, and from the Gauss law we can write Q by A. If the medium is a sphere, then we can write Q by 4 pi R square, because the area of a sphere is 4 pi S. Now according to the definition, E is equal to Q by 4 pi epsilon R square. So if we write D by E, the value is coming epsilon, and D is equal to epsilon into E. Write the expression of the energy stored in the capacitor. So by the definition of the capacitance between two plates is C is equal to Q by V, and then electrical potential V is equal to dW by dQ. So dW is equal to V into dQ. dW is equal to Q by C dQ. So what is dW? V is nothing but the Q by C. V is equal to Q by C dQ. So if we integrate the both side, we will get W is equal to half C V square. W equals to half C V square. It can be also rewritten as W is equal to Q square by 2C. Write the energy density in the capacitor. WD is equal to energy stored per volume. What is the energy stored? Energy stored is equal to half CV square. What is the volume? Volume is equal to area into the displacement. So we can write CV square is equal to epsilon V square by 2D square. So if we put the value, we will get the value of the W, because here we are getting epsilon E into E by 2. Epsilon T is nothing but the D. So dE by 2. So the energy density in the capacitor is dE by 2. What is current density? If the charge is distributed in a given area, then the current density is defined as the constituent as in the given area J is equal to I by A. So J is equal to Di by ds and Di is equal to J by ds. If we integrate the both side, we can get I is equal to integration of J ds, and J is known as the current density. Current density, we can basically three types. One is the convection current density. So it is three types. One is the convection current density. Convection current density is the due to the drift velocity of the electrons. Then this is the conduction current density. If we give the external force towards electrons, it starts to move and the current generates is known as the conduction current density. And last one is the displacement current density. When current flows through an dielectric, this very small leakage current is known as the displacement current density. So as I told, classify the current density: convection current, conduction current and displacement current density. Define conductor. In the simple terms, an electrical conductor is defined as the materials that allow the electricity to flow through them easily. This property of the conductors that allow them to conduct the electricity is known as the conductivity. The flow of electrons in a conductor is known as the electric current. A conductor exhibits the following property in the equilibrium point. A conductor always allows the movements of the electron and ions in them. The electric field of a conductor is zero, allowing electrons to flow within them. The charge density of a conductor is zero. Only on the surface of the conductor free charge exists. All points of the conductors are at the same potential. So actually the many metals are the good conductors of electricity, and this is the reason why the appliances that need to pass electricity are made of metals. The plastic is used for the plastic covering is given to save us from the electric shock or electrocution. Next, illustrate the property of the capacitor and write the expression for it. So there are many properties. Number one property, the most common property of a capacitor is the capacitance. The capacitance describes as the capability of a capacitor to store electrical energy for the given voltage. The capacitance can be increased by increasing the effective area of the electrodes and decreasing the separation between the electrodes. Number 2, working voltage. The maximum working voltage, either AC or DC, can be applied to the capacitor during the entire life of capacitor without causing a failure is called the working voltage. What is the tolerance? The tolerance value of the capacitor is the extent on which the capacitor allowed to vary from nominal value. If the capacitance is 50 microfarad, its tolerance level is 10% plus minus 10%. So the capacitance may vary from 40 to 60 microfarad. Leakage current or displacement current. The dielectric used in the capacitors are not perfect insulators. A small amount of current always leaks through the dielectric, and this is known as the leakage current, or we can tell it as the displacement current. Working temperature. The change in surroundings, the temperature of the capacitor affects the capacitance. If we increase or decrease the capacitance temperature, the capacitor will change. The working temperature of the capacitance is minus 30 degrees centigrade to 125 degrees centigrade. What is the polarization? the capacitor connects to the capacitance terminal must have the correct polarity, that is positive to positive and negative to negative. Next point is the calculate the capacitance of an isolated capacitor. So isolated capacitor charge conducting the sphere has the capacitance application. We know capacitance is for a normal circle capacitance. What is the first we have to, if we have a charge, we can write voltage is equal to again 1 by minus E into D. And what is this? Q by 4 pi epsilon r square into the, if the distance is r or d, we can r, dr. And what is the distance? The distance is from end point to new point. So it is B to A. So if we put the value, we will get the voltage is equal to, the capacitance is equal to Q by 4 pi epsilon naught 1 by A minus 1 by B. Now what is the meaning of the isolated capacitor? An isolated charge conducting sphere has the capacitance. If we take one capacitor of a circle and we are bringing the charge from infinity to the point, we will get the isolated capacitor. So in the case of the isolated capacitance, A is equal to R and B is equal to infinity. A equals to R and B equals to infinity. So if we put the value of A is equal to R, B is equal to infinity, 1 by infinity is nothing but the 0. 1 by infinity is nothing but the 0. So we will get it 4 pi epsilon naught A, and A is the radius. So we can write capacitance is equal to 4 pi epsilon naught into R. So this is the isolated capacitance. So in this session we have discussed about the different important definitions of the capacitance. And thank you all.
Like, share and subscribe. Hit the bell icon for more updates.